If you have questions about today's quiz, come see me. We can talk about it. So we're on 3B.8. This is the last section of 3B, the tangent function. So thus far, we've analyzed sine, cosine, right? So you had to know that tangent was coming because what was left. In the next unit, we'll learn about what they're called their reciprocals. Don't worry, there's more fun to take place. Their reciprocals and their inverses. So crazy. In the next unit. All right, so recall that we briefly talked about tangent in 3.2. We define the tangent as an angle as the slope of the terminal. Basically, it's the ratio between your y and your x, right? So tangent is the ratio between your y and your x. And so when you go around, now that we understand this, the reason why we call it the slope is because it's, think about slope. You learn slope as the change in your y over the change in your x, right? And so if we're thinking about tangent in the same format, we now can kind of build on this. So from this is where we started. Oh, I want it right. Please just let me write. Let me be great. Let me be great. I didn't write that. All right. So tangent can be called the slope. It can be determined by sine over cosine. It can be determined by y over x. However it's presented to you, just understand that that's what it is, right? So when you look right here, this is the relationship. This is why we call it the slope. Because if I'm saying this is equivalent, then it's y equals mx, right? It's the mx plus b part. But your b is 0 because it's going through the origin, which is why we can say it's the slope. Make sense? Okay. And the reason why we just say y over x is because when you're looking at a point, well, that's the change in the x and the change in the y, right? So it all comes together with things you already know. Tangent is just to build on of what you know already from Algebra 1 in terms of slope, and then from previous units in terms of what sine and cosine represent on the unit circle. Got it? All right. So let's dive and analyze it. Your pictures are really tiny, so just look at mine. So up here we have that when we watch slope of an angle changes, we can determine what happens. So when we look here, as we go from 0 to pi, what's happening to our slope? So initially, right here, our slope is what? 0. And then it keeps going. So it's going from 0, and then it increases, right? Getting steeper, getting steeper, getting steeper, getting steeper. And then what's going to happen when I come here? It's going to be at 90 degrees. And at 90 degrees, what does that mean? It's a vertical line. What is the slope of a vertical line? Slope of a vertical line. A vertical line has a slope of nothing. It's undefined. Do you guys remember? So horizontal lines have a 0 slope and go through the y-axis. Do y'all remember that? Vertical lines have an undefined slope and go through the x-axis. Okay. Does that ring any bells from algebra? I learned that in Algebra 1. Oy vux, it was my math cuss word for the longest. I said it. I was that annoying 8th grader who decided this is going to be my cuss word. And so I would just say it in class all the time. You see it, you see it. Yeah. So yes. So that's literally how I remembered from 8th grade and forever that when I have a horizontal line, the slope of it is 0 and it goes through the y-axis. When I have a vertical line, the slope is undefined and it's going to go through the x-axis. Okay. All right. So that's what ends up happening. And because the slope of a vertical line is undefined, so our slope was steadily increasing and then it hit a wall and became what? Undefined. Does that make sense? Okay. So then we came to the conclusion. This is what we'd write. Now that we say the slope is undefined, it is because it is infinite. It's going. So the limit as theta goes to pi over 2, tan theta is going to be positive infinite. It's forever going, right? So then we kept going. We kept analyzing around the circle. So now we're going to go from pi over 2 to pi. So as I look and I'm going from pi over 2 to pi, what's happening to my slope now? It's now becoming negative, right? So my slope is becoming negative. So it's going from we're going slope transition from negative infinity to 0 because it becomes horizontal again, right? And when I'm horizontal, that's a slope of Horizontal is the slope of 0. That's the OI part, right? And then we keep going around the unit circle. So now we're going from pi to 3 pi over 2. And then we hit undefined again. So at 3 pi over 2, we're now undefined. Do we see that? Okay, so that's what ends up happening. So the key concept here is that at all of your odd halves, you're going to have an undefined point. And when we have undefined points, they create what? Vertical asymptotes. Yep. You create vertical asymptotes. Do you see those vertical asymptotes? Notice that I'm saying at all of our negative half points, okay? Because if I'm at only at our odd half points, not negative, at our odd half points, because if it's an even half point, then it's going to be a whole number. Does that make sense? So at our odd half points is how I remember it. So at odd halves, that's where my vertical asymptotes are taking place. So we have it at negative 3 half. We have it at negative 1 half. We have it at positive 1 half, at positive 3 halves, and it keeps going and going and going. It's a tangent function. This is just called the tangent function. It's not sinusoidal because it's not continuous. It's not connected. So it's just a tangent function, and it has discontinuity. So discontinuity. It's a fun word about being respectful. Okay. All right, let's talk about the properties. So I'm going to tell you right now, I made your boxes too small. I tested it out. There's no way you're going to write everything in these boxes, but you should have some white space above. So if you want to write, I'll tell you the things you can write. Like domain is pretty big. So if I was you, I'd write domain above because it's not going to fit in the box. You've been warned. Okay. I've admitted I made your boxes too small, but let's talk about the attributes of a tangent function. So notice that it still has A, B, C, and D, right? So you still have your A. Your A is a little trickier here. It's our vertical dilation. We don't call it what do we call it for sine and cosine? What do we call it for sine and cosine? What does the A in your sine and cosine represent? Amplitude, okay? For sine and cosine, your A is your amplitude. But for tangent, it's just a vertical dilation. And the reason being is that there's no max and min on tangent, right? It's going forever to positive infinity or forever to negative infinity. So there's no max and min to create an amplitude. Make sense? Okay. So A is going to be found by this. It's our vertical dilation. Our period is no longer 2 pi over b, is just pi over b. Okay. Our period is pi over b. Absolute value because period is just distance, correct? Okay. Our phase shift is negative c, our translation. So this is just saying that it's always the opposite of what it is. The negative c just lets you know it's the opposite. X's are liars. That's our horizontal translation. And then our vertical translation is going to be our D. In this case, our vertical translation, it's quote unquote the middle. Okay. It's not our midline, it's the middle of our tangent. Okay. Okay. The middle of the tangent is our concavity. It's our point, not our point of concavity. That's not the word I was meant to say out loud. Oh my gosh. Point of inflection. Thank you. Thank you. Thank you. Well, that's it. I said concavity because it's where the concavity changes. Okay. It's our point of inflection. So the middle is our point of inflection. Point of inflection. Okay. Our POI. Where does our concavity change? Okay. All right. Where did I tell you should write your domain at? At the top because it's going to not fit in the box. Okay. So your domain. Your domain is not continuous, right? It has points where it's not equal because of the asymptote. And because this function goes on forever, we cannot write it as with a bunch of u's showing that there's breaks in our function. So we're going to write it as a rule, as a function. So it's your b, whatever your b is, times x. However, it cannot equal pi over 2 plus pi times k. And k is just a integer. Okay, when you see this symbol, that means, hold on, let me make it prettier. This means k exists in integers. Z represents integers in shorthand. So instead of, you should have did this in algebra with your real number system, but Z is how you represent the word integer. So instead of having to write k as an integer, we write k exists in integers. Okay, that's what this is saying. Is plus pi of k, pi times k. So k is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It goes on forever, right? K can also be -1, -2, -3, -4, -5, -6. And that's where your domain is not equal to. Okay. Which is going to just produce all of your odd halves, which is why I wrote on the graph, your asymptotes are at your odd halves. So at 1/2, 3/2, 5/2, 7/2, 9/2. This is just mathematically saying that I'm at the odd halves. Okay, your range is simple. Your range is easy. It goes from negative infinity to positive infinity. Okay, your y-intercept is also easy. Your y-intercept goes from, your y-intercept is at the origin, 0, 0. Your x-intercept happens on a pattern. The pattern for your x-intercept, it happens at every pi. So at every pi, at every whole pi, you have a y-intercept. I'm going to go back really quick. So you see I have negative pi, 0 pi, 1 pi. It's going to be 2 pi, 3 pi, and it continues. Does that make sense? So every whole pi is where you have a y-intercept. To write x-intercept, thank you. K exists. It's a E and C had a baby. What it is how I've always thought of it. So our x-intercepts, to write the x-intercepts, you write it as a rule. It's pi times k. Oh, and again, k means that it's a number that's in all of the integers. So my intercept is at 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 100 pi, 200 pi. K can be anything as long as it's a integer. All right, what am I on next? Asymptote. So we're on our asymptote. Your asymptote is just reiterating this piece of this, okay? So your asymptote takes place at all of your odd halves. The rule for it is pi over 2 plus pi k. And what again? K is going to be what? An integer, right? K is an integer. So this is the where x cannot equal. Does that make sense? Because it's in asymptote. It's what the part of the domain that it's saying it can't be, right? Because it's an asymptote. That's why it can't be. So maybe don't put the not equal to, because it is where it's equal. All right. Our tangent function, if you rotate your paper 180 degrees, rotate your paper, what do you notice? Is it or is it the same? It's the same. And that's because it has odd symmetry. Okay? AKA it's rotational. No, the graph. Huh? Oh, I forgot the R. You could have just told me that. How do you spell symmetry? Yeah, thought so. I just put it in the wrong spot. That's what happened. All right. So remember how with sine and cosine, we described the patterns as being a max, an intercept, a min, an intercept, a max, right? That's cosine, the cup. Yeah. And then for sine, it's an intercept, a max, an intercept, a min, an intercept, correct? Well, what's the way we're going to remember tangent? Well, to remember tangent, we're going to remember it as it's an asymptote. After your asymptote, you're going to have a low point. After your low point, you're going to have a x-intercept. After your x-intercept, you're going to have a high point. And then you're going to end with an asymptote. Okay, so let's go back and look at that on our table. So what I was saying is you're going to have a low point. So notice that there is a low point, right? So here's our asymptote, a low, an x, a high, and then a asymptote. And that pattern keeps repeating. Yes, asymptote, low, x-intercept, high, asymptote. Asymptote, low, x-intercept, high, keeps going. Okay, your low and high points are going to take place at -1 and 1. Do you see that? So our low and high for our parent function takes place at y equals -1 and y equals 1. All right, so we've learned all that we can learn about the parent function. Now we're going to dive in and solve it, use it, go from there. So up first is our first example. Okay, it says a portion of the function f is shown above, well, below, next to. I tried to say paper. It was above. Now it's next to. The function f can be written as f of x equals a tan b of x plus d, where a, b, and d are constants. Find the values of a, b, and d. Okay. Before you get started, the first thing you need to find always is the period. Okay. So the first thing we're going to find is our period. The period for a parent function for tangent equals pi over 2, right? And for this one, is it still pi over 2? Yes. The difference from here and here, this is a quarter, this is a quarter, and a quarter plus a quarter makes a half, right? To find your period, all you're doing is subtracting from one asymptote to the other. So this is the change in your asymptote. It's a triangle. The period is going to be the change in your... Oh, the parent function is pi over 2. So when we were here, it's not, it'll change. Yeah. But for this one, it's still the same. Yeah. So for the parent function, it is going to be pi over 2. From there, we can then find our b, because pi over 2 equals pi over b. So we can first find our b. Nope, that's for sine and cosine. For a tangent, it is pi over b. Huh? Yes, tangent. Period of a tangent is going to always be pi over b. Okay? The parent function, come back to the parent function. I'm sorry, the parent function is 1 period. I don't know why I said pi over 2. The parent function is 1 period. Shauna was tripping. P equals pi. I was trying to say the rule. Okay. This is a half. This is a half. A half plus a half equals whole. This one's different. It's so your period equals the change in your asymptotes. So like the difference from one asymptote to another. This is from here to here is a quarter. From here to here, that's not a quarter, is a quarter. A quarter plus a quarter makes a half. So your period is pi over 2. This is the rule for all tangent functions. Instead of 2 pi over b, it's just pi over b. So now we set this up and we're going to cross multiply. And that leads us to b times pi equals 2 pi. So b is what? B equals 2. So we have our b. B is done. Next, you're going to find your d. A is going to be the last thing you find. Okay. The next we're going to do is find our D. Your D represents your vertical shift, your vertical translation. Vertically, meaning did my x-intercept move? Did the middle of my graph move? Did my POI move, right? Did my POI move? Nope, my point of inflection is still the same, right? So we know that D equals 0. If they ask you to state A, B, and D, if D is 0, you need to state that D is 0. Does that make sense? Yes. Shift is your vertical translation. Okay. To solve for A, so to find A, we're going to substitute in values. You're going to substitute in values. In order to substitute in values, you're going to choose any point on here and evaluate what the A could possibly be. I'm going to always choose the point that's going to give me a value of 1. Why would I go any harder? So I get 1 right here, right? What's halfway between 0 and pi over 4? Pi over 8. So this is the point that I'm going to use. So for my substitute, I'm using the point pi over 8 f is 1. You're substituting it into the function to solve for your A. So we're doing f of pi over 8 equals 1, which equals A times the tan. What do we get for B? 2 times pi over 8. And I'm going to just, for the sake of writing it, I'm going to write dn, which is 0. And then you have to evaluate the A. So unlike with sine and cosine, we could use our max and our mid to figure out our A. With tangent, you have to do a little bit more work, okay? Which is why it's imperative that you find your B and your D first. Does that make sense? Okay, so evaluating, we get 1 equals A times the tan of pi over 4, because 2 times pi over 8 is pi over 4. What is the tangent of pi over 4? What are the x and y coordinates at pi over 4? It's what, Randy? 1. Good job. Because y divided by x is going to be 1. So we end up at y, 1 equals A times 1, which just means your A equals 1. And now you have found all 3 pieces. So just because they're listed in alphabetical order, do not try to solve them in alphabetical order. Does that make sense? Because you're not going to be able to solve the A without your B and your D. Capiche? Question? All right. What are the ordered pairs at pi over 4? No. Ordered pairs, unit circle, pi over 4. No, it's not. Pi over 4 is in quadrant 1, and it's the middle. It's your 45.
45 degrees.
It's 45. Huh? Unit circle. Oh, we're about to start having unit circle quizzes then, because we are having weekly unit circle quizzes. We are gonna have to, because you guys apparently are not remembering the fact that you must remember the unit circle. No, you're not. Unit circle quizzes coming back. Get ready. Weekly unit circle quizzes. Huh? Yes. Unit circle. If I have pi over 4, that's 45 degrees. Its ordered pairs are square root of 2 over 2 and square root of 2 over 2. Your tangent is your y divided by x. If my y and x are the same, what is the tangent? It's 1, which is why Randy said 1. The tan of pi over 4 is 1, which is how we ended up with A equals 1. Okay? So when we start having these pop-up unit circle quizzes, don't be mad at me. You did this to yourselves. Okay? All right. Here we go. Working backwards. If I give you this function, 4 tan of 2x plus 5, can you tell me what the period is? . The period is what? How do you get 4? Remember, for tangent, period equals pi over b. And what is my b? 2. This is a question we should never get wrong, guys. It's pi over 2. So the period is pi over 2. That's it. Whatever your b is. It wasn't a trick. It was not. It was one that you should not get wrong. You had to do no math. You just had to remember a definition that the period equals pi divided by your b. And what is your b? 2. That's it. All right, all tangent problems are going to be multiple choice. Okay. So all your tangent problems are going to be what? Multiple choice. So let's look at an example of a possible multiple choice. Okay. So here we have, let g be the function defined by g of x equals 2 tan x divided by 3 minus 1. Okay. Which of the following gives the vertical asymptotes to the graph of g? Okay. We wrote down the rule to find our vertical asymptotes. The rule to find our vertical asymptote is based off of your b value, right? So the first thing you have to do is figure out what is our b. What's our b? Our b is based off of here. It's 1/3, right? So we know that our b is 1/3. Agree? So we know, and then from there, what did I write down in my notes to tell you as hints? What is the fastest way for us to solve this? Yeah, let's just do the long way. We're gonna work our way out of it. All right, so we have that our x over 3. What did I write? I'm looking at my notes. Oh, there we go. Sorry, brain fart. Remember right here, we wrote our asymptotes is x equals pi over 2 plus pi times k. That's our rule for asymptotes. Okay, so our pi over 2 is where we are starting. So we know that x plus 3 has to equal pi over 2. For our asymptote rules, they start at pi over 2. But because we've shifted, we've changed our x's, right? We've manipulated our x's. It's a dilation. It's 1/3. Whatever you want to think about it, your period is essentially just a horizontal dilation, okay? You're saying it's starting, growing faster or slower. It's a horizontal dilation either way. So our vertical asymptote rule is that it's pi over 2 plus pi times k, right? Y'all remember that? Wrote that down. So the first thing you have to do is figure out what is our x. And how do I solve this? Cross multiply, right? I wanted the words, buddy. So we end up with 2x equals 3 pi. And then we're going to do what? Divide by 2. So we know that our x has to be 3 pi over 2. Once you establish your x, it should eliminate everything else. Is x equal to 3 pi over 2 here? No. Is x equal to 3 pi over 2 here? No. Is x equal to 3 pi over 2 here? No. So the answer is C. To find the 3, that's where you are, what is that thing called? Your B.
Did they say where k is constant?
No, k is always an integer. K is going to always be, well, a constant. It just means that it's not a variable. It's a number.
Yeah, but is there any point?
No, there really isn't. Just ignore that. Yeah. I copied this problem from somewhere. I don't know why they made that k a constant. I don't know. But no, it's an integer. A constant is an integer. It can be any number, but it's specifically an integer. Don't let this fool you. This is supposed to say integer. Okay. But what I wanted to reiterate to you again is that as long as you remember that your asymptotes start at your odd halves, then you can always figure out where your starting point is after a transformation. Okay. So if this had been 2x, let's just say it had been 2x, right? To find out my starting point, I would just take 2x over 1 and set it equal to pi over 2. Make sense? And then I can figure out where it starts. And that would help you eliminate where does your asymptote start and the pattern continues from there. Okay. The growth of the pattern depends on the length of your period. So this 3 comes from my period. So P equals pi divided by your B. And in this case, my B is 1/3. Does that make sense? Which is why this is 3 pi. Because we keep change flip and this is going to become 3 pi. Okay. So this piece comes from your odd halves. This piece comes from using your period. But in all theory and reality, I think this, based on the questions I've seen, as long as you can do the beginning, the rest will eliminate the rest. Okay? Because again, tangents just going to all be multiple choice questions. Got it? On the non-calculator. It's on the non-calculator, not the calculators. All right, so here we have which graph best, well, which function represents this graph. So we have tan of x over 2, tan of x over 2 minus 2, tan of x over 2 plus 2, tan 2x minus 2, tan 2x plus 2. So the first thing we got to figure out is what is our b, right? And then, or d. D is going to be the easiest thing for us to figure out, right? Where's our POI? Where's our point of inflection? Where's our middle of our graph? So POI equals our d. And where's that at? At -2. So notice that it's at -2. So automatically we know D equals, so I can eliminate B and D. So now we got to figure out our B by first finding our period. Your period equals, what's the distance between your asymptote? So from this asymptote to this asymptote, what is the distance? 2 pi. So our period equals 2 pi. Because we know our period equals 2 pi, this has to equal pi over B. So we set up our proportion, and we're going to do what? Cross multiply. So we get 2 pi B equals pi. Divide by 2 pi. And therefore, B has to be what? 1/2, because the pi's are going to do what? Cancel out. Cancel out. So which one has our B as 1/2? A. Okay. Yes. All right. Take out your unit circle or use your brain. I don't care which one you're going to do, but you're going to need your unit circle.
You go back to
C. Okay. All right. So this is use of unit circle. Knowing where our ordered pairs are, what things equal in order to evaluate tangent. Okay. Any value on the unit circle is free game for the non-calculator part of your test. Do you hear me? Any ordered pair, any radian on your unit circle is free game for the non-calculator parts of your test.
like the first one, so
So, tan pi over 6. So you're asking yourself, y over x, what is the y coordinate at pi over 6? What is the y coordinate? It's going to be 1/2. What is the x coordinate? Square root of 3 over. And then you're dividing. So we keep change and flip. So you have 1/2 times 2 over the square root of 3. 2's cancel out. And you're left with 1 over the square root of 3, which equals square root of 3 over 3. Yes. The what? 8? Yeah. Okay. So again, you're identifying tangent of theta equals your y coordinate divided by your x coordinate, right? So at each point, you're finding what's the y, what's the x, keep, change, flip. What's the y, what's the x, keep, change, flip. What's the y, what's the x, keep, change, flip. Okay, I'm going to do this one with you, and I'm going to stop, and you're going to do the rest. Got it? So let's do this one just to verify. So at tan of pi over 4, our y coordinate was square root of 2 over 2. Our x coordinate is square root of 2 over 2. So therefore, the tangent is 1. Yes? All right, go. That'll be great. So here we go. Checking yourselves. I can't reiterate. The unit circle is super duper duper what?
Important.
Important. All right. Oh my gosh.